Okay, let us see now when we have two figures cut out of a lamina. So, find the center of gravity of the remainder formed below after removing some parts as shown below. Now this one is a circle, of course. Now you start this one, they are moving the square. How do I know that it's a square? Well, that means that this side is equal to this side. So that means they are removing the square because of this side here. So they are removing that square. So what are you going to do? You first reconstruct it again so that you know the length. So because this is from here up to here is 2, it means that also from here up to here is 2 centimeters. Why? Because this side here is equal to that side, they are equal. These two sides are equal. As simple as that. Now, how do I do? So from here up to here, there are 8 centimeters as you see from the diagram, and from here up to here, there are 6. So if this is 1, remember this is the radius. So evidently this one is going to be 1. So 1, 2, 3, 4. From here up to here, that is now 6. Means that now the balance here from here up there is going to be 2 centimeters. That's how we know. When you add this, plus this, plus this, plus this, plus this, plus this, you should be able to get the 8. Now, what about down here? From here up to here, it's 1. From here up to here, it's 2. So that is already 3. So meaning, from here up to there, we are going to be having also 3 centimeters because this is 6. When you add this, plus this, plus this, you should get that 6. So the diagram is almost there. So our task now is first to get the areas. So I'm going to call this one area 1. I call this one area, okay, I call this one area 2. Then I call this one area 3. As simple as that. So to get area 1, I'm going to get its length times width. So 8 times 6 is going to be 48 centimeters squared. So there we shall say, okay, and then here I'm going to select W be the weight per unit area. Why? Because these are lamina, these are to get the weight, because center of gravity deals with the weight. You get the area and the weight per unit area. But because you don't know the weight per unit area of these three figures, that's why we need it to be W. So now my first weight, 1, is going to be this times the weight per unit area. That will be the weight now of the lamina. And I come to area 2. So my area 2 is a circle which is 5 into the radius 1 squared. That's going to be 5 centimeters squared. I told you that take pi to be 1.3.14, which is going to be 3.14 centimeters squared. So now my second weight is going to be, again this time is W 3.14 times W. So I have now the weight of now this when I come to the square, so area 3 is going to be S times S, which is going to be 2 times 2, which is giving me 4 centimeters squared. So now my weight 3, what am I going to do? I get the area times the weight per unit area, which is W. There we shall be getting our weight. We saw where these ones are coming from some previous lessons behind there. That's why I'm just quoting. Then, because weight, we say for uniform lamina weight is proportional to the area. So the proportionality constant is the weight per unit area there. So after getting that, now we come and we get the weight of the remainders. After removing this and this, now it means that we are going to be having this out. So we get the weight of the remainder. Weight of remainder. We get the big, which is 48, then minus these ones, 3.14 minus 4, all of this W, and so we shall get there. That is 48 minus 7.14, which is leaving me. Here we are getting 40.86 W. So the weight of the remainder is 40.86 W with ease. Now, we need now to come and get the center of gravity. So the center of gravity for this one, I'm going to say it's going to be D1. So I need to get the coordinates, but its weight is going to be acting there, W1. So what are the coordinates? Because this is the rectangle, we said the weight, the center of gravity of the whole is going to be in the middle. So from here up to here, if from here up to here is 8, then from here up to the middle it's going to be 4. From here up to here is 6, meaning this is going to be 3. So you have that. Now, the question is, what are you considering? So, consider, you have to state, consider AD and DC as axes. So that's why I'm getting from this and also from this. So from here up to here, 4, then from here up to here is 3. Just that I don't want to call this, that's why I'm putting it there. Now, let me call this one grid 2. So from here, our grid 2 is going to act here, in the middle here. That's where our grid is going to be. But the question is, how are we going to get our grid 2? Now, we get from AD and from DC. So from AD, remember from AD, as you can see, first of all, let me clean this so that it looks. So this is my G2. How am I going to get the coordinates of G2? To get the coordinates of G2, now we remember we want the horizontal from AD. Because this is vertical, we shall get the horizontal. So we get, know that from here up here we have 1 centimeter. So we add from this side up. So this is 2, this is 4, this is 5, this is 6. So meaning it is having 6. What about from now this C? Remember, from here is 1, this is 2, this is 2 also. So meaning from here up to here we have 3 centimeters. So now I will add from here up when I reach there. So I'll be adding 3 plus 1, which will give me a 4. So I have my 4 there for the center of gravity of this. You add this from this C, because they are the axes we consider. That's why I'm adding from here, that is 3, up to there, that is 1. Because the center of gravity of the circle is always in the middle. So now, let me, because also the center of the square is going to be in the middle, G3. So to get the coordinates for G3, they are going to be, we add it from here. Because it's acting in the middle, so if this from here up to here is 2, it means that from here up to here is going to be 1 centimeter up to there. So that's why I'm going to add now 2 plus 1. I'll be having the horizontal distance from AD, which is 2 plus 3. I mean plus 1, which is 3, comma. What about the vertical distance now from this C? So I'll add this, then plus from here up to here, of course, it's going to be 1. If this is the square and this is 2, then from there up there, it's going to be 1. This is going to be 1 centimeter. Because this is the square, so I add 3 plus 1, which will give me 4. Of course, we have seen G1 already. G1 is the center for now, this, the big denominator. So from here, I think for it to see, it's going to act in the middle. It's acting in the middle also because it's a rectangle. So we get a half of the length, which is 4. Then a half of the width, which is 3. This one is 4, 3. Then here we have corresponding weights. So the weight 2 here is the weight for this weight 2 is 3.14 W. Weight 3 for this one is weight 3 is where? 4 W. And weight 1 for this one is, so it is 48 W. Now I'm considering the whole row. So that's when I get the whole, then I remove these remainders. I'll be getting that of now the remainder. When I remove these ones, they remove. I'll be getting the remainder. That's why I'm getting the weight of the whole. Okay, so from there, now our X bar, Y bar, the center, the coordinates for the center of gravity, we shall get W1 into X1, Y1. Now we subtract all these ones, they removed. They removed this and they removed this. So we subtract off weight 2. We put the coordinates of weight 2. We also subtract weight 3. And we put the coordinates of weight 3. The whole over still, as you see the order, W1 minus W2 minus W3. That will give us our answer we are looking for. X bar, Y bar is going to be W1, weight 1 is 48 W. Where is it acting? The coordinates, because the weight is acting at the center of gravity of that particular thing, which is 4, 3. Then minus weight 2, 3.14 into. Now we have, where is it acting? It's acting at 6, 4. From this axis we chose. Then minus weight 3, which is 4. This is W. 4W into now, where is it acting? It's acting at 3, 4. The whole over W 48, W 3.14 W minus 4 W. And so from here, our X bar, Y bar is, then press the calculator. Okay, these are the answers I'm getting for the first part. When I get this times this minus, this times this minus, this times this, I get 161.16 W. Then I get this times this minus this times this minus this times this. I'm getting 115.44 W. Now all over. We subtract this and we got 40.86 W, of course. Then when we separate, we get 161.16 W divided by 40.86 W. Then this one we get 115.44 W, the whole over 40.86 W. And so here my X bar, Y bar is going to be the first coordinate. I get the, so here I'm getting 2.8, 253 for the small cases. Then up I get 161.16 divided by 40.86. Here I'm getting 3.9442. And therefore, my center of gravity is at now 3.9442, 2.8253. taking which axis AD and BC as axis. That is going to be my answer there. Okay, so some people are saying you give this to 1 decimal place because when you are plotting on a graph, you need 1 decimal place. But I'm giving for so that you can able see. You can just round off to 3.9, then 2.8. It's okay if you want to round off, no problem. Okay, so that's it. I wish you the best. Now we are going to see another example when we are going to see, don't worry.